Hello everyone, I am Rahul Shirodkar from IP second year, and without wasting your time, I will like to welcome you and introduce you to our guest, Mr. Nikhil Naikade. He is the SolidWorks champion, SolidWorks user group leader, and he has passed more than 50 SolidWorks exams, which is a very big deal. He is also founder of Paritech 3D, which is a 3D printing 3D printing startup, and now he will give us knowledge and his experience about 3D printing. And now, sir, I would request you to come and share your knowledge with us. Thank you.
Well, thank you, Rahul. Thank you for such a sweet introduction. I would like to thank the entire students committee, the coordinators, and the faculty members of the institute for giving me this opportunity. And hopefully, by the way, I really hope you all are doing well. You all are safe and sound. So hopefully we are hopefully at the end of the pandemic very soon, and things are going to look up for all of us. So this session is going to be intended for all, right from beginners from zero to little experience up to intermediates. And I am pretty much sure by the end of this webinar, you can start 3D printing either as a professional career or as a hobby, maybe from the comfort of your house, and start a small factory right at your desk. So should I share my screen? I will request Rahul to change the layouts to admit all, because that's going to come up popping again and again. So just admit all the participants.
Yes, sir.
Okay, sir, we will wait for 5 minutes more.
Okay, all right.
Sir, you can start your presentation.
Okay, all right. So as I said, this session is going to be intended for all. Rahul, could you remove my host access? It's popping again and sort of getting diverted towards that.
Yes, sir.
Yeah.
But if I remove you, you will not be able to share your screen.
Oh, okay, all right. Understood. No problem. Cool. So let's get started, guys. Firstly, I thank to all the coordinators and the faculty members for giving me this opportunity. Really appreciate the participants' interest also in this new technology. I really appreciate your efforts towards committed learnings. So this session is going to be intended for all, right from beginners, from zero to little experience up to intermediates and professionals. And as I said, I'm much sure that you might start a small factory at your desk, opening this as a hobby, as a business as well. So now, guys, imagine yourself in your situation wherein you are working in some projects, and in between that projects, you, while working, found out that you have lost a connection with your teammates, and there isn't sufficient parts, or maybe the raw materials, or maybe few things which you need for the project to work upon, at your available site. So what in that case is what we will be doing. So either you will be going out surfing for those part, or maybe consider topsy-turvy situations like this, wherein you cannot go outside and you really need those parts to fulfill the completion of your project. Isn't it a great idea to have some technology besides you that will do the work, and you wish to complete your project in that stipulated time? So that's where 3D printing is coming into picture, as you have your own desired products whenever you want them, how you want them, customized to just the way which you are looking for to meet your specification. And this is what really makes 3D printing so special in my belief. Well, welcome to the world of possibilities. So after the introduction and the technical presentation which I will be going, we will have a small Q&A session at the end. And one thing for sure, I want you guys to completely interact with me throughout the course of these presentations. You can use the chat box provided and you can drop your queries. I will be able to check them out in real-time view, but I will try to address that as soon as the presentation gets finished, so at the end. And this is going to be delivering a more practical perspective of the industry. I'm not going to bombard you with a lot of theories and concepts which you guys have been doing since years now, okay? So for more than a century, the products we design are constrained by the capabilities of the processes such as machining, molding, casting, and the economics of manufacturing have been limited by the need to invest in fixed tooling and equipment. So if you take around the traditional manufacturing techniques like forming and casting, they are somewhere trying to provide to just capable of providing the sufficient needs of the companies, the industries. However, we are leading into the industry 4.0, and with this perspective, if we still stick to the traditional manufacturing techniques, which right happens, this is not going to fulfill the demands of the complete industries, right? So that's where 3D printing is actually coming into picture, or additive manufacturing in general. So to begin with, the agenda for today's session is going to be introduction, which will be followed by a complete process workflow which happens in the industry. It will always be an industrial perspective of things. And later I will be providing some practical demos and application, and at the end also we will be discussing about the future of 3D printing with some instances, some real life examples which will be more captivating and interactive to look into. So to start, let me ask my audience, you have been engineering students. I think rather than saying, I should be asking you, tell me what are the difference between subtractive and additive manufacturing, or let me know the advantages of additive manufacturing before subtractive manufacturing. You could use your chat box. I will be noticing it. So I will try to log on from one of my screens. I want some more people to try. Come on. What do you think will be the advantages of additive manufacturing over subtractive? Even the coordinators could try this out. Come on, everyone. What do you think? Okay, so Manthan is telling you could, in subtractive, we remove material to make a part, right? But what are the advantages of additive over subtractive? To Okay, for more details, let me explain you in brief. So, subtractive manufacturing technology is something which you have been following since years. That's the traditional manufacturing technique, wherein you could see the image I have attached. There is a complete raw material which is used. It undergoes through some sort of processes, and after those processes take place, we get our finished product. Let's take an example of, let's say, CNC machines or maybe lathe machines which you have been working with. If you are trying to do operations like turning, milling, facing, this, what are these operations doing? They are cutting or removing material from the original raw material, right? So this is what subtractive manufacturing techniques happen. Now, to classify into two different categories, I have mentioned the very basic classification. Again, there are various methods like forming, casting. Again, types of manufacturing process are vivid, but in general, there are two. And additive manufacturing, what happens is you are going to add material layer by layer. It is going to deposit material in order to form a final finished product. So that's what the two are being classified into. So complex and integrated design, very good. So Harsh is saying complex and integrated designs can be manufactured. An extremely good point to consider. Less wastage, yes. I think some more people can try. Don't worry even if it goes wrong. There's no one here to come judge you. Layer by layer formation and design material perfectly. Okay, accepted. So overall, if you try to consider the advantages of additive over subtractive, you will be hearing all these basic advantages, like there are less materials being used, so the cost of the material goes down. Then if cost of the material goes down, it is again economical, ergonomical, and then since part is generated immediately in the final shape, there is no extra involvement of any tooling activities, no processes, no jigs and fixtures, additional supportive materials required. At times they really don't need a complete assembly line. Skilled workers are eliminated. So this all completely gives you a great advantages of additive manufacturing over the subtractive. But if you try to think in a detailed way, why are industry moreover focusing on additive manufacturing ways? So there comes some really hidden advantages which a lot of industries don't really reveal. It is easier to make changes, whenever there is new product development. Even if at my startup, we completely work on new product developments to produce products which are manufactured for the first time in India. So while manufacturing such kind of products, if I try to go with this traditional manufacturing techniques, it is literally impossible to have design revisions. And let me tell you, whenever there are companies who are working on new product development, there is R&D which will be taking place. Design revisions are inevitable. Okay, so you will be finding a project manager being assigning a job and the project engineers coming back with multiple revisions of design, and this cycle goes on continuing. So it is really not sufficient, or let's say economical, to go with traditional manufacturing techniques to provide the essential requirements. Okay, so that's where additive manufacturing is going to come into picture. So since we can make easy changes, it eliminates many constraints of conventional manufacturing. The lead time decreases eventually. Okay, now since the lead time increases, there is less number of prints required, less cycle time, and to your surprise, one most biggest advantage which the additive manufacturing industry is going to give is, let's say from the year 1800, okay, there was industrial revolution took place, the French Revolution, you had studied it in the history. Right then there was a priority given to mass production, since there were factories which were coming out in picture, there were companies being established. The human efforts were replaced by machines, and machines performed a lot of work. So mass production was given an utmost priority back then. But today we have the people, agreed, and we also have the demands of these people. Now the people who are going to produce the demands are nothing but the customers in the market. Now their demands are going to increase on an exponential rate. Will those mass production technique be capable enough to provide the sort of demands which the customers are having? Really not. So that is where additive manufacturing is prioritizing mass customization over mass production. That's the benefit of using additive manufacturing technique in this recent era. So I could see few people trying, yes, they're less costly and more efficient. Exactly, additive manufacturing technique reduces the cost of the products by literally 70% if you are manufacturing a prototype or so. These are things which I will be talking in few minutes, but I'm letting you know just in case. So let's take a note about the history of 3D printing. You will be amazed to see that there was this very good instructive article published in a United Nations newspaper. And this article says that there are machines which have been invented which makes 3D objects from drawings. Up to a certain extent, I could agree that you are familiar with these stuffs and you are well acquainted with the technology. But back then, this was something invented. So this was something really boon in the industries. So two people who invented this. This was the first SLA machine. Again, what is SLA? We will be going in detail. So while these concepts were taking into picture, there was a person named Charles Descartes who coined out the term 3D printing and additive manufacturing in general. So he's been also today even considered as the father of 3D printing, and he back then had made a company named 3D Systems Corporation. So we still consider his insightful achievements right there. So to define 3D printing or additive manufacturing could be defined as a technology in which you form your products from an digital CAD file, okay, in the form of a computer aided design, and that creates a solid three-dimensional part additively, layer by layer. When I say the process additively, I have to focus on the word layer by layer. So there are different additive manufacturing techniques which are available in the industries, or 3D printing in general which are available. We will be going towards the most major classifications of techniques. Alright, so let's start with the first most common and highly used by the industries. The first method is fuse deposition modeling, or we can say FDM. So in this method, what happens is a strand of plastic model is pushed through a heated nozzle, and that heated nozzle is going to move in a program pattern which places the heated plastic strand in the shape of a single layer of the part. Okay, so this machine is going to print material layer by layer in additive process with the help of a solid filament. The raw material here which we use is called as a filament. To explain you in detail, you could see that there is a material which is loaded. So this is what we call it as a spool. There is a build tray which is present, a nozzle, the material which is the nozzle, and then the nozzle moves in a program pattern in X, Y, and the Z directions in order to print that original part. Now it is having a dual extruder printer, so there is also another material which is provided for the supports. Again, coming to all these things in detail in the course of this webinar. So to make you sure that you imagine how the things are happening, I have added an animated video for that. So you could see that this is the nozzle and your build plate where your printing is going to be taking place. You could see, if I zoom in a little bit, the nozzle is really moving in a program pattern, and it is covering the X, Y, and the XY axis for the time being. So immediately the first layer gets covered, that's the X and your Y axis, it shifts the layer and it is moving to the next consecutive layer, and then again completing the same process. Now this nozzle is going to move in such a program pattern. This pattern is going to be nothing but the file which the designer, a CAD modeler, or a design engineer has designed, and it has sent it over for a 3D printer to manufacture it. So this process goes on, and at the end you will be able to see the final product coming out of the picture as a consequence of all this layer being added one by one. Look how that's happening. So I hope you are understanding till here. You can drop in the +1 in the chat box, or maybe if you are getting this. So this was the fuse deposition This was the fused deposition method, which in also European countries also called as FFF technology, fused filament fabrication, and you have coined a lot of terms for that, but in general we call it as FDM process. Now what happens in FDM printers, you will be noticing that most of the printers don't really have a build envelope, they are open. However, certain printers do also have a complete enclosed build envelope. That depends upon what sort of material are you printing and what sort of technology are you using it. So again, which will be covering the entire thing into the details over a few minutes. So this is for the second method of 3D printing. I will say I am classifying it on the basis of methods. You can also categorize it on the basis of the subcategories, which will be FDM printer, which will be again been classified into LOM, that is laminated object manufacturing, where an entire sheet of material is being printed. Hopefully we will try to consider the most prominent methods in this first section. So second method is nothing but the selective lithography apparatus, or the SLA process. It is an additive manufacturing process that works by focusing an ultraviolet or a UV laser on a vat of polymer resin. Okay, a UV laser light falls on a vat of polymer resin. Now what happens here is there is going to be a high frequency laser light which passes through 2 or let's say 3 lenses being rectified, and a galvo motor system acts in between in order to direct that laser into a vat of polymer resin. So the basic difference between FDM and SLA is the raw material which we used for 3D printing in FDM process was a filament, that is a solid material in general, and here we are using a liquid resin. So that's the key differentiation factor between the two processes. What happens is, pool of liquid resin is heated up to a specific temperature. So this is been heated, here the resin is being stored, okay, and this is basically a thermoplastic resin which is being used, the PPE, and then a projectile layer moves through the liquid and hardens the resin at the point of contact, wherever it is going to contact. Now whenever the resin shifts to another layer, the build tray is going to move through the roller, and the next consecutive layer, the laser is going to act on that next consecutive layer, which in turn is going to solidify or harden it. So this process goes on continuously, and at the end what we receive is a very fine and detailed part. If you try to compare the quality, FDM process is going to in general give you certainly a less quality of 3D printing, but SLA process is going to surely give you a high quality print. So since it's coming with all this technology, it is going to be a little expensive. Again, it is also available in desktop sizes, and here you could see the laser is being controlled by small mirrors that move the laser around. So this is to depict it with the help of an animation. We could see that there is a vat of polymer resin which has been stored in this particular box. So this is what you call as a vat. Note that this entire process has been highly enclosed, since the resin is UV sensitive and they really need to protect it from the direct contact of sunlight. So it has been highly enclosed. This is something what happens in and out the machine. So this is the vat of polymer resin which has the resin stored. This is the laser unit which depicts the laser, and there is a galvo motor system. The part and the role of the mirror is to just redirect the laser light which is coming in between, and to apply it towards the point of contact where the designer has designed the things, okay, just to come out. Then what happens is, when it solidifies the first layer along with the support structures if they are needed, and your part is been completed for that first layer, there is an elevator which is going to shift itself, and a rotalector blade which moves to and fro, which indeed is important in order to clean the uncured resin which sticks predominantly over the last consecutive layer. So this is going to completely evade that uncured resin, and it is going to wipe it out to a certain location. However, this resin can also be used after some curing process. So you could see that, I will tell you this in detail. In additive manufacturing process, you are firstly using less material, you are using the optimum method, and again the waste, which I don't call it as a waste, but the uncured part of the filaments could again be used. So you could see that this industry 4.0 with this technology is truly building a sustainable ecosystem for manufacturing processes. I hope you agree with my point. So this is how the part is going to look when it is removed from the vat. Now when it is going to remove, you also have the resin which is stick to that. I will be talking about how to cure these things in detail. So the third and the most important method is selective laser sintering, which happens in the industry. Now in the first method, what we saw was there was a solid filament which was used as a raw material. In the second method we used a liquid resin as a raw material, and then this is the third method of 3D printing, which you call it as selective laser sintering, and it is an additive manufacturing process which is similar to SLA, but instead it directs a laser in a 3D space and hardens a point at that contact. Okay, a laser is still used in the process to produce the solid part, but it interacts with the powder instead of the liquid resin which we see in the previous section. Now this laser is definitely, if it's going to harden a powder, it needs to be of certainly high frequency. So this is going to be of high power laser light, which is certainly a CO2 laser used to fuse small particle, and the materials which will be used here are nylon. You will be using SLS process for some high order machines like PA12, some sort of material, ceramic and glass powders even the process could be optimum, and you could see that the section of video which will be depicting is similar to the previous one. Only note that the difference here is there is going to be a powder instead of a liquid resin there. So you could see this powder supply container. There is going to be a roller which is going to clean the uncured powder, which will be going to be stick on the first consecutive layer which it printed. Again the same process happens to be taking place. Here we do have a complete different and a big section for the uncured powder to store, which will be again used after the course of printing. So again you are using the waste and promoting the raw materials to again get reused in the process. So this is again cleaning the uncured part. It is having a dedicated collection container because it is a powder resin, and a lot of stuff can be done. So this can be again reused over a course of time. So this was the entire theoretical part. I hope you got it digested, and it comes without saying that 3D printing is not just limiting to these basic methodologies. You again have the SLM process, that is the selective laser mentoring, wherein you use high order materials like metals, basically aluminum, titanium, steel are high in demand for using. It is used to create metal parts specifically. So industries who are economically sound, they use these all processes in their ecosystem. So to conclude, you may see that the technology which we are using is going to depend upon the type or the product which we want to manufacture. So suppose if you want to manufacture functional parts which can be used into functionality testing, you can go with the SLS process, wherein nylon or PA12 can be used easily, and you could achieve the importance, or you could really replace the exact material which you were been using. So for an instance, if you are using, or let's say a metal bracket for a part which was applied some boundary conditions, some loading conditions, you could usually use that with the help of this 3D printed as a replacement part. And there are industry which has still been focused, which I will be covering in the application sections later. So the basic steps which will be involved, and this is the new methodology which goes into picture, is a CAD file is being created by a designer, a design engineer, and that CAD file is going to be shifted or maybe sent to a machine. The machine is going to 3D print it, and you will be able to get that object ready before you. However, it is not really that simple as it seems from the pictures above. The entire industrial depth of the process goes without saying that when you design the CAD model, it needs to be converted into a file format that your 3D printing machine could accept. But let's say if you are using an Autodesk software and if you are trying to use it for designing and 3D printing, the Autodesk software's file format is nowhere going to be accepted by any 3D printing machines. Well, there are dedicated printers which nowadays have the technologies to accept those files as well, but traditionally you need to convert it into a generalized file format, which then a third party software is going to interpret and accept, so that it converts into a file format which the 3D printers can accept. So I have depicted the entire process with the help of this sort of a schematic flowchart. So what happens behind the scenes is a 3D printing model is being converted into a neutral file format which is generally accepted for 3D printing. We call it as the .stl file. Now, why I've written .stl is it's the most commonly used file formats while we are into 3D printing. There are several types of file formats like .3mf, .amf, .additive manufacturing file, .obj. So varieties of file formats are available depending upon which type of slicer software you use and what it accepts. So what is slicer software? It is nothing but a third-party application which you will be installing along with your integrated CAD module. It is going to convert that STL into a G code. A G code is again a neutral format which most of the 3D printers accept. It's the same way in which you have seen your CNC softwares working and converting the G and M codes in the for the CNC machines to work upon. Same way you are going to generate a toolpath for that 3D printer to work upon, and this .g code file is being accepted by the machine. It interprets this file and then 3D prints the object, and that's where you get the object in picture. So this is how the entire design workflow takes place behind the scene. We will be able to get into the details and with a practical demo also. So let's see, if I am having a file, I'm using currently the Parametric University's Creo software. So let's say I had designed these things few years ago. I am having a solid file format which I created using the software, and let's say if I want to 3D print it, okay. So what I will be doing here is I will be following a generalized method, okay. So this method goes common for all the softwares which you might be using. So I will be going file and then save as. So the type of file format which I said US, we will be using a stereolithography file .stl, as it's one of the most common file format used for 3D printing in general. So I am using the STL file. I will locate a directory for that, okay. So let's see if I'm opening here. I will be getting some extra additional options. So this is the two formats which are available, the binary and the ASCII. These are two most important STL file formats. We could always click on tessellate with the shapes in order to get a good height, but not now, since I would like to reset it to the original profile. So I will just go and click OK. Now, could you see the file is being converted and it is been saved in that directory, and now could you see that it is been converted into a mesh like structure? Can you see these meshes? Please could you drop in the chat section. Okay, I hope it's visible. So this is nothing but your .stl file. Now your slicer software is going to interpret this file. It is not going to recognize your native CAD files, okay. Keep this in your mind. It is a very big common which a lot of people face. Now what this STL file comprises of, it comprises of a lot of facets. You could see these triplets, these triangles. Now 1, 2, 3, 4. These are nothing but your facets. A combination of such triplets is going to form a mesh. Depending upon, it is going to vary upon the type and the size which will be included, okay, which will be evolved. So for instance, if you see that the geometry is really getting organic right here. Okay, alright, so you could see they are themselves changed their shape, and they have converted itself to match the shape of that geometry. So at very curved edges you could see they are very small, but where there is no need, they are formed themselves certainly a large number of a large size if you compare. So this is what I wanted to showcase you. The formation of STL happens with this triplets, or let's say combination of facets, to form that mesh, and this file will be then exported for 3D printing into another base software. So let's consider another one. Okay, so I've opened a part model for you. Alright, the way in which I'm going to do the same thing, again I will go to file, save as, and again I will be opening the STL file. Okay, so to save it in STL, I will be having few options there. Again, to choose the type of file format we want, I will be selecting the type of resolution which is really needed. The coarse resolution is going to detect that the formation of that triplets is going to be really coarse, okay, of less quality basically. But if I go to fine, you could see that it has changed to a complete sharp circle, which it was not before. So that's the difference between the type of resolution which is needed. Again, if you use a fine resolution, your number of facets are going to increase. Again, I will hit OK, and I will save, let's say, for that particular session. So you could see again the software has converted, and it is allowing me to save that file to it is asking me to save whether you have to save. So the number of triangles for this small part formed was 492. It was 29684 bytes of size, and the file format will be binary type of STL. So let's say if I am saving it to that location, you can again get your CAD file there. So that is again been saved there. So this was all about basically saving a file into an STL. So this file will be, the STL file will be then being shifted to third-party application. And when I talk about third-party application, one of the most wonderful application which is available in the market right now is the Ultimaker's Cura. Now why Ultimaker's Cura? Because it's an industry-leading company in the names of 3D printing, and it has their own industrial grade 3D printers which are extremely important, and they are extremely being used extensively in the markets at a high end range. So this is where I have imported the file in another third party software. Note that in certain high grade softwares you also get an option to integrate the file or the third party applications with the CAD software. So let's say if I talk about SolidWorks, I'm going to add a, let's say, macro. So if I add a macro in my software, it is going to directly convert that part, and it's going to reduce my hustle of working with the number of steps for converting that into an STL. However, certain high-end products also have an integrated features which is going to allow you to 3D print the structures. For an example, in SolidWorks we have the print 3D feature. So you could see that the same feature is been available as we saw in the third-party software. So there are high-end products in the market. The CAD softwares are also allowing us to allow stuffs to 3D print. I will be explaining you the 3D printing process in the third-party application for the time being, but let me just cover the types of materials which are involved in the 3D printing process as such. So firstly, let's talk about the materials. To briefly say about these things, we have materials which are available in 3D printing, but these materials are also a finished product of some raw materials. Okay, now the raw materials which might be used in industries will be depending upon the type of material you have to produce. So let's take an example of ABS first. So ABS stands for acrylbutyl acrobutyryl nitrylstyrene. So ABS is a widely used material in the industry. It has a high glass transition temperature and it has less density. It produces most rigid and strong parts, due to the which the 3D printing industries is extensively using this material, having a melting temperature of about 210 degrees Celsius, making it possible for most of the type of base variants of printers to even print this. Secondly, we will talk about the polylactic acid, nothing but your PLA. It is a biodegradable material. That means it is made up of some eco-friendly, environmental friendly materials. It is nothing but made up of a dry sugarcane rush, which you get after it is soaked and all the liquid is being evolved. So this is a raw material which we use for making PLA. That's the very reason why it is biodegradable, environmental friendly. Polylactic acid, it softens at a temperature. It is easily to regulate. The melting point is below ABS. It is having a melting point of about 180 degrees Celsius. It is bioplastic. So whenever you try to 3D print something with PLA, the 3D printing process doesn't produce any fumes. However, in the ABS, however, we could see some cases, some instances wherein few fumes will be produced. However, they are not that toxic as such, but yeah, they might allow you to take care about. So the third material is TPU, thermoplastic polyurethane. TPU has been classified into 2 or 3 categories based upon the degree in which it is going to flex. So TPU is a flexible material. It is going to regain its original shape after the compression or after the evolution of the forces. That's the reason why we could use TPU in regions where we want flexible objects to be printed. The 3 categories of TPU processes are 95A, 98A, even you get 87. So these 45A also. So what are these types? It is based on the type of material used and the degree of flexation you get. Nylon is the most, you could say, costly material which is available for 3D printing. You use basically nylon for functional parts which are going to be functionality tested. The melting temperature of TPU is 248, nylon it is 285. So you could imagine that it requires high-end 3D printers, because reaching a temperature of about 300 degrees is not a cup of tea for all the 3D printers out in the market. So nylon is going to be 3D printed by most high-end, high-efficient materials of 3D printers. It is going to require considerably a good ambient temperature maintenance. So the 3D printers which are going to print nylon should be completely enclosed. The same is not the case for materials like PLA and ABS. So this is what the most common materials about 3D printing are, and in general I have let you know the information. So to begin the basic terminologies involved, I want you guys to come up and try and compare these two parts. One amongst them is a 3D printed part, and one amongst that is a injection molded part. So if you believe the left one is 3D printed, click in the chat section L. If you believe the right one is 3D printed, click in the chat section R. Come on, I want some more people to try. If you think the left one is 3D printed, type L in the chat box. If you think the right one is 3D printed, type R. You could have a close, a distilled and a wise look towards those pictures. So before you guys keep on trying, I will be able to see those in live section. So I will be covering some basic terminologies which will be involved. A 3D model is something a designer is going to design it, a CAD designer, maybe design engineer, and it is sent for 3D printing. 3D printing resolution actually depicts or is involved somewhere related to the layer height of that object, the greater the resolution, the lesser is the layer height for which the 3D printing object is going to be printing. The 3D printing volume is that envelope, or we can say that vicinity or surrounding in which your 3D printer could be able to print parts, beyond which it won't be able to print anything. Filament or resin, in FDM we call it as filament, in SLA we call it as resin. These are nothing but the raw materials which we use in 3D printing. Fifth point is the layer. So while 3D printing I showcased you, there was the FDM printers which were printing first layer, then the consecutive layer. So the layer are those material which are deposited when the 3D printer starts printing the, or maybe melting the material out. Layer height is going to be the distance of each layer, or the height of that layer which the 3D printing nozzle is going to print. The less the layer height, the good the finish of that particular 3D printed model. But layer height is going to also make sure that the model which you are going to 3D print is requiring time. So it is directly proportional to the time which is required. So let's say if you are having a very less layer height, so it is inversely going to increase the time which is going to require for the 3D printing process. So that's completely inversed. We could say that a build plate or a build tray is going to be a platform wherein your 3D printed models will be rested and they will be printed. It could be made up of a certain ceramic or aluminum material. We could also see build plates being made up of glass. I discussed about the file formats .stl, .obj, .3mf, varieties of file formats which are available. Completely depends which suits your purpose and which your SAS software is going to accept. Now this is something very important, infill. Now infill is the amount of material which has been deposited inside the part. That's why it is called infill. So let's say if I talk about a component or a part which is having 100% infill, I mean to say the part is been completely filled with the material and it is true solid. Let's say if I am talking about a 10% infill, that means the part is having 90% of void space and it is completely and it is filled 10% of that. Supports are nothing but the additional pillars which you build for your parts to withstand the overhang distances. Okay, they are going to help you build a pillar where the overhangs are present, so that your 3D printers when they print they don't warp the design. So I could see a varieties of answers again. So if you closely look around, you will be finding a strand of material, maybe a leftover you could say, behind this particular component. So this is nothing but a bottle top, and it is majorly been manufactured by injection molding processes, but you could see that it has left over some parts, right? So that is why the right one, as many of you have tried to answer, is a 3D printed part. You could see wisely there are some strand of material being left over. So in order to just make sure that this goes away, to eliminate this type of leftovers, there is an additional process being involved in the 3D printing industry, which we call it as post-processing. Which brings me to my next slide. It is the process in which you remove the supports, the leftovers, the fixed and the unclean part of your 3D print, either with the help or with the methods like sanding, as in case you have seen the picture right there, or maybe using some third-party components. So for an instance, post-processing is going to involve steps like removing the supports, cleaning, fixing the print, sometimes curing or hardening. So if you are talking about SLA, you will be saying that there is a UV sensitive resin. So when you remove the part from that particular 3D print, you will be able to soak it into the direct sunlight, or maybe an established UV sensitive system wherein it is going to cure that film. So surface finishing is also another way. You could use a buffing machine to just clean and surface finish the product, or maybe you will be using a sandpaper I tentatively try to use sandpapers of, let's say, 300 600 grits, depending upon the type of surface finish which I want on those components. Coloring is again another process in which a post-processing way in which you could try to also 3D print it in a common color, let's say white, and then you try to give it your desired color. So again, this is coming into post-processing way. You could also soak some materials in water. This is also possible. The technology has also made this possible. So let's say if you are printing a component and you are attaching the supports with a second material which is called as PVA. So PVA is a water soluble material. The moment you are going to 3D print it, you just need to soak it in water and your part is going to completely remain in the water, and the supports which have been established in that 3D print are going to be drained away, or let's say soaked in the water. So these were all the post-processing ways which happens. For parts which we will be printing with ABS process, they are going to require acetone, and maybe the parts which you will be using by PLA, it is going to require isopropyl alcohol as a post-processing agent we talk about. So isopropyl alcohol available with 70% concentration, 90%, depending upon the type of smoothness and finish which you want. You could see these parts which are printed with ABS or PLA, and then they are been rubbed and polished with those post-processing agents which I talked about respectively to get that high quality, nice surface finish. So this was all about the post-processing materials. I will like to showcase you the basic FDM printers which is coming in the industries. So this is what I have modeled. I explained you about the nozzle, the build plate. This is the nozzle assembly. Again, there will be a strand of material going ahead with a burden tube which will be feeding here, and the nozzle is going to move in a direction of x-axis. The build tray will be going to move in the direction of y-axis, and this extrusion assembly entirely will be going to move in the direction of z-axis, which is going to allow the machine to 3D print the complete object. So this is how a typical FDM printer looks like. So to now explain you the importance of file part orientation, I will be focusing in my previous screen. So this is a file which I have created in SolidWorks. Let's say to go for the slicing, we need to completely understand the importance of orienting that file part. So for the people who think this should be an ideal orientation to print, keeping the surface which I have highlighted as the base should click left in the chat section, and for people who think this should be the orientation of the file part which I have highlighted, they should click right in the chat section. Okay, so let's check how much people are getting involved. Even the coordinators can try, everyone. Okay, so Rahul is saying left, Abhijit is saying right. So again, I will repeat, if you think this is the orientation, you please click, you please say right, keeping this as the base. And if you think this is the orientation, keeping this as the base, you please click on left. Okay, Omkar is saying right. Jay Prakash is saying left. Kunal is saying any. Okay. Again, come on, some more people could try this. Left, okay. Pawan is saying left. Yash is saying left. Amulya again saying right. Okay. Now what happens in industries is, I see that in the chat box you have basically tried to address one common question about the future scope of this and job opportunities. As a design engineer, what you will be judged is the way you are going to 3D model that part. That's absolutely true. But to send a part for 3D printing is going to also require an ideal 3D printing orientation. Selecting an ideal 3D printing orientation is extremely important because it is going to depend and it is going to, let's say, tell you how the part is going to manufacture. Now, when I asked you the question, which should be the ideal print orientation, most of the people said right. Few of them also said left. Now, imagine if I would have used right side, keeping this as the base as an orientation. There are two such instances, number 1 and number 2, wherein there are cutouts in the part and these cutouts are going to require supports. So the moment you put in supports in your 3D printed object, what are you doing? You are going to increase the print time, you are going to increase the usage of material, and when there is increasing print time, increasing usage of material, definitely there is also going to be involved a third process, that's the post-processing process. So there are again time, effort, energy being invested. Now consider, for the people who said the left side keeping this as the print orientation, there is only one such instance, like this circular cutout which is present, which is going to demand support. Correct me if I'm wrong. So this is what I wanted to explain you guys. The file which you will be sending for 3D printing, no doubt there are software which are going to interpret the best possible orientation, but not possible they are always right. Okay, so you need to understand the orientation property, and as a design engineer you should understand which should be the most suitable part file for orientation for 3D printing. To be honest, to keep it general, people tend to select a base which is flat, covering major portion of the area, but they don't consider the later aesthetic views and the considerations while 3D printing the file. So for an instance, as a lot of you said, the first part is going to be the ideal print orientation, which should be in this particular way. So let's see, when I import this into my third party software, what features do we have? Look, when I import it, again if I try to delete it, go click on import, I will selecting that part and I'm clicking OK. Look, it has imported it in a completely absurd way. So this is not at all preferred. Alright, for the people who are new to 3D printing, they just ignore these ways, and when you try to I hope you are getting what I'm trying to say. If you try to 3D print it with this particular interface, it is going to demand a lot of support areas. Now the softwares are not going to say that okay, you think and you try to make sure that you are using the correct orientation. It's up to us what we have to use. So what I will do here is I will change the orientation by turning the model, and look, it's done. So I have changed the part orientation. Let's see the majority of settings which we get while we need to take into consideration while we 3D print. The part file could be enlarged, it could be also diminished based upon the type of model which you want to print based upon your needs. So if I want to scale it up, let's say by 20%, 120, hit enter. So it is scaled up. Okay, now what's important here is to make sure that the supports reach to the right parts. You could see that there is an area which is highlighted by red in color. If you could see, this is the area which is going to require additional support material. So when I go click on to some settings, what I will choose here is optimum layer height which is required for this to be printed. So I will be choosing a layer height of 0.12 mm, and for the time being this suits my settings, it suits my needs. I will go and select the infill to 10%, hit enter. So the complete product will be filled 10% with material and 90% will be the void space. Thirdly, what I will try to choose is a printing speed. So let's say the printing speed is the speed which the nozzle is going to move to and fro in order to print that thing, and pretty much I have selected generate support. so it is going to generate the support there wherever needed, and I usually tend to use a support density of 0%. So I am a bit consecutive about spending my each gram of material which I tend to spend. Okay, so when I hit on slice, the software has given me two valuable instructions. Okay, this is the total print time which is going to require in order to manufacture this part with a 3D printing layer height of 0.2 mm and 10% infill. It is going to consume a material of 106 gram. If I click on preview, it is going to showcase me an entire preview of stuffs which happens when the part is being 3D printed. Now you will be saying me, hey Nikhil, why did not it use supports right there? It's because I have decreased the support angle because my printer is somewhat capable to producing supports or circular edges which are in this way. So supports, I forgot to mention, are used extensively when you are required to 3D print objects which are having overhangs greater than 45 to 55 degrees. Most of the printers won't be able to print material with that percentage of overhang, that angle of overhang. So if your printer is capable, you could go ahead. So this is what the part is going to look like. So if I go dig down a little bit, it is going to showcase me how it's going to be available from inside. So let's say if I have increased, I've went inside and it is going me an internal perspective of the object. This is the infill of 10% which I mentioned you, and if I try to showcase you, you could there's a nozzle which is moving, and you could see that nozzle depositing layer by layer. So right now we are at the 40th layer of the part. You could see the number here, and this is what the direction in which the nozzle is traveling. The nozzle is printing the infill, and then it is again going, after it's done printing that, it will again go and shift itself to the 41st layer, that is the next consecutive layer, and it again continues the same process until it reaches the top. Well, that's the process being involved right there. So let's look ahead about some of the objects as a part of application. So this is again a customized laptop stand which I 3D printed. Again a functional part. We used a PLA material. You could see the finished quality, how it's been used in the industries. So this is how the 3D printing industry is working with. So let's say I have another part. So it is I am designing it again in Creo 5.0. So you could see me taking manual dimensions of a customized remote case. Something remote is a thing which we always tend to forget. We forget where we keep it. This could really be handy. I tried to design it in a software, so it's a common process of designing it. You try to take manual dimensions, and you could really use the functional parts wherein it's been stored. So after I design the part, I would simply save it as an STL. I will open it in the third-party software if the software is not integrated within a slicing envelope like this. So in the another environment, I will try to slice it down, save the file, and then it again goes for manufacturing. So same way, again a customized mobile stand. These are some quick my self applications of 3D printing. You could see a functional prototypes been used. So this was a aluminum 6075 material which was needed in order to use for a particular differential brackets. If you are belonging to SAE and Bharat team, you might be knowing what are differential brackets. So to replace that model, we have to use some other materials. So this is again a functional prototype which I made. These are applications of 3D printing industries. Again a tablet case. If you really want to just have this is the good quality about and advantages of 3D printing, having a 3D printer and knowing the stuff which goes behind the scene. You could create objects on demand. You could customize it just the way you want. You won't believe this was a iris mechanism which I designed, and it was 3D printed in place. Okay, this was completely 3D printed in one particular place. So this is not an assembly, this is in one place 3D printed. Again, some more products like a customized headphone stand. So this is how the 3D printing industry is. You could be using your own particular cases and you will be designing stuffs just the way you want it and get those 3D printed. The monitoring your 3D prints is again an important step which is taken into consideration. So you could also, there are advantage of the 3D printers, advanced 3D printers, which help us allow to monitor the 3D prints even if you are not in the vicinity. So the real-time monitoring is also available in certain cases. The practical applications of 3D printing in majorities of industries goes, well, let's start with automobile industry. You could see this Lamborghini Aventador. It was the first flagship model of Lamborghini. Most of the parts were 3D printed while it was in the R&D stage, and still it is a 3D printed technology. It is a car which is using, it's a company which is using 3D printing technology in an extensive way. Okay, so this was the first instance. You could use 3D printings in end user parts like I showcased you. Food and fashion, even there are 3D printers which can print food, precisely chocolate. Confectionery industries, I'm talking about, it can also print chocolates. In the medical industry, you can also print. Bio printing is a process which, not getting much into the detail, it is also capable of 3D printing tissues and organs, extensively used in the medical and healthcare sector. So if you want to showcase live surgery to students who are into biomedical field, let's say, you can also 3D print prototype of a heart model, maybe an organ which needs to be simulated, and you could create such real life scenarios wherein 3D printing could come into picture. Defense and aerospace industries, again, one such thing. Industrial designers are again getting a lot of demand these days because the use of 3D printing in industry is increased at such an height that there are functional prototypes which have been redesigned, and designers are, that's why, being in demand, since 3D printers used to create quick parts and industries really want this to happen. Again, automotive and aviation industry, it is also possible, as some of the folks in the chat even said, it is possible to make complex and 3D print integrate shapes which a lot of industries, the injection molding industry won't be able to make them. As I said, confectionery industries, which is 3D printing chocolates. For the food preparation, it is again another application. This is something interesting. So if you are trying to simulate some results, if you want to check for some functionality testing, there are in the medical industry physicians who have also tried and tested out 3D printed materials like an entire human jaw. When it comes to this sort of materials, there are several considerations should be taken into picture, as the density of the material should approximately be matching with the density of your human bone. Materials like bioprinting materials like titanium are used in these cases, and this is eventually the next industrial revolution which is taking place. So we could also create objects on demand with the help of 3D printers, customize the just the way we want it. Lots of toys, and if it's into for a particular mass customized toy for some sort of children's, it is also happening. And a lot of toys are being manufactured for children, basically for in orphans who are special children with some different disabilities. So again, some replacement parts, if you want to quickly make some replacement parts and you really don't care about buying an entire tool suite of products to just for replace that one part, again, complex structures could be 3D printed. So that's where your injection molding industry is going to lag. Your traditional manufacturing won't be able to make objects such complex and integrated. So this is what the 3D printing industry is helping the human mind. Like, so artificially arms for disabled. So even me, I've worked on certain projects wherein we are making 3D printed prosthetic arms for those who are not able to those who are disabled, they are not able to achieve a human arm like that. So 3D printing could be used in such a way that the medical industry, the medical and healthcare industry, and literally any industry in the markets could certainly take benefits from it. As I said, components on demand. You might be able to see that in aerospace and in the space industries, there are objects which needs to be of minimum density and giving maximum performance. So 3D printed light parts could be certainly on demand there, wherein you will be able to achieve your requirements with certainly the less density which it goes with. So Liberator here is another device, let's say a gun which was invented, and it was the first 3D printed and tested handgun in America. So what was the story is, the parts were 3D printed, the parts were designed in some different locality, the parts were tested and 3D printed in a different locality, and the entire gun, okay, was 3D printed and it was able to shot a bullet from that. So the firing pin is also not made of plastic, though it is easily crafted from a metal nail. So this is the vivid applications of 3D printing and the future scope which I discussed right now. So right now you could also see that the government is promoting Startup India initiatives. It has been providing aids for 3D printing houses. So when you go into 3D printing for construction, it is going to drop the construction cost to around 45%, and that's where the luminous advantages of 3D printing comes into picture. So the question comes, should you invest in a 3D printer? Yes, to improve your creativity. It is a really great tool to educate young children and help us to educate them, be ready for this industry 4.0. 3D printing also helps them, it is environmentally stable, it saves a lot of time, effort, energy, and yeah, it is fun, and believe me, it is sort of an addiction when you get started. So this is what all about 3D printing in general. So to conclude, I wanted to say, industry manufactures products, and additive manufacture is coming into a lot of limelight these days. Additive manufacturing fundamentally changes and let us create objects on demand using digital data that let us reimagine how we redesign products and how we define their performance, how we make factories more efficient and reduce our time to market. As a result, we are considering additive manufacturing to be cornerstone of the next industrial revolution. So with additive, it's really about expanding that design space. It's promising to go change the traditional paradigms of how we approach to creating something. Additive is going to change the way engineers are thinking about their job. It is going to be the next cornerstone for industrial revolution, and it is going to change the way the production systems and engineering in general thinks about. Eventually, implications of additive manufacturing and for designing and production are for reaching and probably beyond our imagination. But it's still early stage, so now is the time to get started. So this was all about from my end. If you have any queries, you could reach out to me on my social media handles. Maybe you could reach out to me here on LinkedIn or connect me over Twitter as well. But for now, if you have any queries, if you have any doubts, I will be able to see them in the chat box. You can ask your questions. You could go ahead with, I believe, Rahul, few of your contacts were having some questions, right? The attendees were leaving some questions before this.
Yes.
So Deepak is you're saying on your socials, I saw you designed bottle and headphone of boat. How did you calculate the dimensions? Look, while you are into product design and development, the moment you hold a product in your hand, you are going to reimagine and visualize the dimensions being involved. Okay, those things comes directly into your mind, and a picturesque image of that product is straight away been formed. So some designers also use the method of proportions, the method of ratios which goes. So let's say if you are choosing the overall height of a particular product or a commodity to be 20 millimeters, and if in general, if you talk about, let's say if you have discussed about headphone stand, so ideally the breadth and the length should be proportionate to that. With that, you could certainly calculate a rough dimensions and you could design products.
Hello, am I audible, sir?
Yeah, you are.
Thank you, sir, for your great presentation. I would like to call Vikram for asking the question which was taken at the registration time. Vikram, you can start now.
Yes. Hello, sir. My name is Vikram Prasad Kashyap. I am
Mm-hmm.
from Mechanical first year. I would to like to put some questions asked from participants during registrations. The question is, we would like to hear about your journey of startup from beginning.
Okay. So what happened is I used to do a lot of designing work. I used to be involved into freelancing process. So basically what I used to face is whenever few clients used to reach out to me for getting, so the projects were industrial projects sometimes it would be student projects also. So the clients which who used to reach out to me always ended up saying, hey, do you know someone who could get help me this manufacture by 3D printing? And then I had few friends of mine who used to merely work upon 3D printing in general, so they were not acquainted with the field of design. So people want to again go and search out to few different individuals who will help them get these parts manufactured. That's the moment when I thought, hey, why shouldn't I try this with our own? And then I tried learning 3D printing and designing, which I was already knowing. So that's how it got started. So I helped those people to get all their services under one roof, and this is what's actually required. Okay, nowadays you as engineer should be able to think about the problem statements and how you as an engineer would be able to overcome that. So a person who is coming to me for getting a particular concept or new product developed, getting ideated, he can get the prototypes even getting manufactured with me. So he won't be able to go outside and search for other people who could do the same work. So that was the motivation. That's how it got started.
Yes, sir. Sir, my second question is, what was your mindset when you started?
The mindset was to reach more and more number of people so that they could, try getting back to me for all their queries, for all their problems, wherever I might help them to. So if you have seen, there is industries which requires prototyping in the initial stages. Now when it is coming to prototyping, you really require real-time engineers which can also give them suggestions, offer them suggestion like, hey, this needs to be the design changes. If you want to go with that intent, you could change the design and it will specifically suit the part to the most. So the mindset was to be well equipped enough to give such kind of suggestions and changes to the customers and the clients, to all the engineering fraternity, so that they could come again and get those demands, those things ready for you, and you get a passive source of income from that.
Hello, sir.
Mm-hmm.
I'm Manthan Sunwanshi from Mechanical third year. My
Yeah.
question is, what are the main points that we should consider while setting a 3D printer for the first time?
So for setting a 3D printer for the first time, if you are going to assemble it yourself, make sure that you do the things correctly. There are electronic components being involved in a 3D printer in the assembly, like suppose limit switches, the components which you need to actually you need to input. The components are delicate, so try using fixing them with utmost attention. This is what I could recommend. And get the things learned before you get it started. Okay, so don't you just have a printer, let's try something out of curiosity. Ask people who have done it, ask people what they have faced, problems which they might have conquered. This will really help you, because success stories doesn't really matter. You could really learn from other people's mistakes. That is why what I could recommend.
Okay, thank you, sir.
So, what are the beginners' mistake that I can avoid? I'm starting 3D printing.
Okay, so the beginner's mistake which you could avoid is really understanding the intent of producing a part. Okay, so if you have a part which needs to be manufactured with an intent of achieving, let's say, a high grade finish, to work with a feature providing high grade finish, you can certainly try to, eradicate some other feature as such. It's the same way when the seating arrangement of the cars are being designed and manufactured. Companies try to look more towards the safety perspective, even though the ergonomic perspective and the aesthetic perspective is been is been not coming into picture. So that's what you could try to relocate. If you try to make sure all the features is been in the same part, then it is going to somewhere increase your decrease the efficiency, increase your cost, and also involve a lot of time in doing that. Understanding the way why 3D printing is important is what I would recommend. Secondly, it is very important to essential that not all designs are meant for 3D printing. Understand the requirement of your designs. Okay, design for additive manufacture is yet again a different concept and a subtopic which comes into picture. You should be able to understand the principles of designing while you are into 3D printing. Look, working on a 3D printer and 3D printing the stuffs is not a tough job, but to know which parts to 3D print, which components we could go for a better manufacturing process is something you should always know and understand, where you could differentiate. That is what a beginners can always try to understand.
Sure, sir. Thank you.
Sir, there is a question from Ajit. Ajit Yadav.
Okay.
What is the scope in 3D printing? Can we choose this as a profession?
Yeah, so just discussed about the entire scope and future scope, what you call in 3D printing. You can also choose it as a profession, but just try to stick and get the knowledge at get the subject matter knowledge in the field. Always try to get access to this is a new industry again coming into picture. If it at times is something new in India, 4 years or 5 years down the line, this is something which is going to bloom. You have seen in countries like Dubai, they have literally put restrictions for 3D printing houses. You cannot go beyond a certain limit. So their extensive development and growth has been already taking place. You could also consider the same opportunities, provided you believe in the technology, you believe in the process, and you have the desire to learn it. So it's definitely going to be beneficial for you. Do we have any other questions?
So, would you like to say something to the students who have heard 3D printing in this session, means for the first time?
I would say that this was a complete basics of the basics. There is still a lot of information. Even I would say I'm a beginner who is trying to learn things each day. Try to, if you want to really make a career in this field, you try to learn something at least 1% a day, which will turn out to be 3600% after the end of the year. The power of compounding. try to learn as much as you can, and this is what I want to showcase. The main intent of coming here and giving this session was to, you know, help you guys to get this process understand. Try reaching out to your friends who are new to this, who are passionate enough to learning new things, and this could be the transfer of knowledge deserving students like you all. Really appreciate your efforts towards this commitment learning, guys. Strive learning hard. Yeah, go ahead.
Sir, I'm new here and I really don't know anything about this course and what you have used means that application, whatever you have used, and I don't know anything about that. So, can you please tell me which app did you use and how a beginner can proceed about that from starting, very starting?
So, to very starting, I believe in your academics you might have the subject of rapid prototyping. If not, you should be able to learn the basics of how 3D printing processes takes place. Then, to get a practical hands-on, you try learning designing first. Use any software, any tool. Okay, the stuff which you asked, the application, it is not really going to matter. Okay, a lot of students face the same doubt: how to get started, which software, which app to use. There is nothing called a software. A software is just a tool. Okay, you use any tool, it's just like a calculator. But to use that calculator, you should be able to understand the mathematics behind it. At times what happen is we try to go directly jump onto the practical perspective without understanding the subject matter knowledge which has been involved. Try getting that first and then jump on to the practical sessions what you saw today.
I think all questions are done now.
Feedback form is provided in the chat box. Please fill the form for the certificates. And now I would like to request Mr. Manthan to give thanking speech and to close the session. Manthan, you can.
Thank you, sir. On behalf of Mechanical and Tech Industrial Tech team, I would like to thank Guru Ghanshidas University for providing such a tremendous platform to learn and grow under the Tech Fest Equilibrio 2022. I would also like to express our sincere gratitude to our today's speaker, Mr. Nikhil Naikade, for kindly giving his valuable time to share his valuable experience with us all today. I want to also thank all the participants for their active participation and hope all of you have enjoyed the session. I would also thank our executives and core members of the Mechanical and Industrial Tech team for being always energetic and making the event successfully. And once again, thank you, Nikhil sir. And in future also we will be connected to you for your guidance, support and knowledge. Thank you everyone.
Thank you guys, thank you for having me. So with your permission, we will close the session. Thanks to all the participants who actively participated and interacted with. Really appreciate your efforts towards this commitment towards learning. Thank you guys.
Thank you, sir. It was pleasure to being with you.
Thank you.